All right, we're going to start trigonometry, specifically right triangle trig. So we've got SOHCAHTOA, and SOHCAHTOA is how we remember our three main trig functions, sine, cosine, and tangent, and what to do with them. So with sine, we use the opposite and the hypotenuse of a triangle's sides. So let's look at this example here. So if we are looking at the sine of angle A, you always do, with the trig functions, it's always of an angle, and then we set that equal. So sine of angle A is right here. So the opposite side to angle A is BC right here. So that is on top, because opposite is first. It goes SOH. And then we've got the hypotenuse, and the hypotenuse is always the one across from our right angle. So our hypotenuse is AB. Okay? So we would have side BC over AB. Now, it would be the same, you'd use the same method even if you are using angle B right here. So the opposite side to angle B is side AC. And then we still use our hypotenuse AB on the bottom. That does not change. So we still use this hypotenuse in both. All right, you're never going to do the sine or cosine or tangent of the 90-degree angle. It will only be the other two. All right, so then we have cosine. Cosine uses the adjacent side and the hypotenuse. Okay, so CAH, C-A-H for adjacent and hypotenuse. So if we are looking at angle A to start, the cosine of angle A would use the adjacent side, which is AC, and the hypotenuse, AB. Okay, so the adjacent one is the leg that is right next to it. We never talk about the hypotenuse as being adjacent or opposite. The hypotenuse is just the hypotenuse. So then you do the cosine of B. So instead the adjacent one this time is actually CB, and our hypotenuse is still AB. And those would be in a fraction. You'll see once we start getting to more examples. All right, and then lastly is tangent. TOA is for opposite over adjacent. So tangent is the only one that you do not use the hypotenuse. So if we are doing the tangent of A, if it's opposite on top, then we go opposite is BC, and then adjacent would be AC. And then if we want to do the tangent of B, it's just the opposite because the opposite side is AC and the adjacent is BC. All right? So let's try out this with some examples. So if we have to find the sine of R, sine equals opposite over adjacent. Okay, so we go to R, and the opposite side is 4. So 4 goes on top. And then hypotenuse, this is always our hypotenuse across from our right angle, is 5. So that would be 4/5. And we could simplify that if we needed to, but that is already simplified. All right, so we can go ahead and do the sine of S. If I'm working with S right here, the opposite side is this 3, and our hypotenuse is still 5. All right, so then we would have 3/5 for the sine of angle S. All right, then we can go to cosine of R. Let's erase this. All right, so the cosine of R has to use adjacent first, so 3 on top, hypotenuse on the bottom, which is 5, because cosine is adjacent over hypotenuse. Then the cosine of S, the adjacent is 4, hypotenuse is 5, so I have 4 over 5. And then lastly, tangent. Tangent is A over H, or TOA, so adjacent, TOA, tangent is opposite over adjacent, So we have SOHCAHTOA. So R, the opposite is 4, the adjacent is 3, so tangent of R is 4/3. And then if we want to do S, the opposite is 3, the adjacent is 4, so that would be 3/4. All right, so those are the ratios for this right triangle. Let's go on to the next page. All right, so we've already seen how to find the trig functions using SOHCAHTOA, but something you might also need to do is just find the sine of 37 degrees, because we always do the trig functions of angles. So if we're talking about angles, first of all, we always want to be in degrees. So on your calculator, what you will need to check every time that you get your calculator from now on is you need to go to mode right here and make sure right now it's highlighting radian. We need to go over and highlight degree. Anytime your calculator gets reset, it's going to go back to radian, so you have to check every time or else you will get answers wrong. Then you can do a second quit to get out of it now that we're in degree mode. All right, so if we need to do sine of 37, we can look right here. We have all of our sine, cosine, and tangent buttons right in the middle. So I will just do the sine of 37, and I know it's degrees because I changed the degree mode, and we'll hit enter. So that's going to be 0.602. We'll round to the hundredths place. Whoops. 0.602. All right. Now we can do, and I'll show you guys actually what's going to happen if you stay in radian mode. So the sine of 37 here is negative 0.644 if we're rounding to the hundredths place. So definitely not the same number. You need to make sure you are in degree mode at all times. All right, let's do the cosine of 75, and that is 0.259. All right, and then our tangent of 14 degrees is 0.249, rounding to the thousandths place. All right. So make sure you're always in degree mode. So now our calculators are already in degree mode, and we're going to start solving problems with trig. So most of the time you will get a problem where you are solving for a missing side. So first thing you need to do is decide which trig function you have to use. 37 is going to be the degree that we use because it's the one that it gave us. So let's label all of our sides. So opposite, the adjacent, and always our hypotenuse. So then what I like to do is notice that I know things about the adjacent side and I am trying to find the hypotenuse. So if I'm using A and H and I'm using SOHCAHTOA, I know I should use cosine because cosine uses A and H. So cosine of 37 equals, and then it should be adjacent first, so 11 goes on top, and then hypotenuse, x, goes on the bottom. Now I can show you how to solve for x for this, but what I like to do is remember if the variable is in the denominator, that means divide. Okay, so denominator, divide. They both start with a D. So what you do is always the number first. So we'll do 11 divided by the cosine of 37, and we get 13.77. So x equals 13.77 if we are solving for x. All right. Now, example 2, if we look at this one, 57 is going to be the angle that we use. We'll label all of our sides. So we have opposite, adjacent, and across from our 90 is always our hypotenuse. So this time, I'm using the opposite and the hypotenuse, which tells me to use sine. So sine of 57 equals 10.8 over x. So again, our variable's on the denominator, so we will divided by the sine of 57 And let's round to the hundredths place again. So x equals 12.88. All right, now if your variable was on the top, unfortunately there's not an example for that. Variable on top means times. Okay, so top times, they both start with T, denominator, divide. And the number is always first. We'll do more examples with this in class. All right, the other problem you might get is where you have to use an inverse trig function. And that is because what's missing here is this angle. They're using a theta right there. We can also call it x. It doesn't really matter. All right, so there's our angle. Let's label our sides: opposite, adjacent, hypotenuse. All right, so I am using the adjacent and the hypotenuse, which tells me to use cosine. So it's always cosine of my angle is just x in this case, equals adjacent over hypotenuse. So if I need to get to this x, I need to do the opposite of this cosine function, which is an inverse function. So x equals the cosine inverse of 4/5. So if you look right above cosine, it has cosine to the -1. That's what we want to use. So we'll do second cosine of 4/5. And we'll get that angle x is 36.87 degrees. All right, and the last example, we are finding x right here. So label opposite. Across from here is our hypotenuse, and over here is our adjacent. That's an H. All right, so I know I am using my opposite and my adjacent side. O and A means tangent, so tangent of my angle equals opposite over adjacent. So to solve for x, I'll have to use the tangent inverse of 4/13. So second tangent of 4 divided by 13, and I get x equals 17.10, rounding to the hundredths place. Oh, and that's in degrees. All right, so go ahead and bring this in, filled into class, and we'll do lots of examples with this.